Part of what we're doing here on Delta Math, we're going to be dealing with the congruence via rigid motions. So we're going to be able to tell whether these two figures are going to be congruent based on if we can map one figure to the other one using only rigid motions, meaning reflections, rotations, and translations. If we can do that, and one goes directly on top of the other one, only using rigid motions, the only way that happens is if those two figures are already congruent. Now what we're going to see with this one, we have a dilation. It's going from big to small, and then it's going to slide over to the left. So just by having that dilation, we know it's not going to be congruent because you're using a non-rigid motion. But the way this works, you're just going to say, okay, well, what's happening? What's happening with the shape? So the very first thing that happens, you have a dilation. It's going from big to small. So we'll have a dilation, and these are all going to be centered at the origin. It's going to have a scale factor of, now we got a bunch of options. Well, since it's getting smaller, that means the scale factor's got to be less than 1. So it's got to be one of these fractions. It can't be 3 over 2. 3 over 2 is bigger than 1. So that would actually make it get bigger. So any of these options, one of these is going to be right. So let's look and see what the numbers are. We only need to look at one point, because if all the points are moving by the same scale factor, we only look at one, and I'll be able to tell where we're at. So we're going from -8, -2 to -4, -1. So the -8, to get to -4, you have to divide by 2. And to get the -2 to the -1, you got to divide that by 2 as well. So that's a scale factor of 1/2. Your half of -8 is -4. Half of -2 is -1. So we're at -4, -1 based on just taking that point and cutting it in half. These are going to get kind of tricky when it comes to the fractions, but you just got to take your time, make sure you figure out, it's whatever you can multiply the point originally by to get to the new point. So if I multiply -8, -2 by 1/2, then it gives me -4, -1. So just keep in mind, whatever your scale factor is, you multiply the original point and see if it gives you the second point. And then it's followed by a translation. It's going to just slide. After it gets here, it just slides to the left. 1, 2, 3, 4, 5, 6. It's going to be 6 units to the left. So to the left, 6 units. Then it also wants to go ahead and you got to make the statement. The two figures are not congruent because non-rigid motions are being used. And then there it is, and it tells you. Okay, so let's do a new problem, because I know it's going to be kind of tricky for you to begin with. Same thing. We're going to use the same drop-down menus. Now, this time, it's a smaller shape. It gets bigger, and then it reflects. So it's getting bigger. We're still dilating, so the first thing we're going to do is a dilation, which tells us already it's not going to be rigid motions. So it's not going to be congruent figures. We're going from -2, +2 to -4, +4. So we would multiply the original point here by 2 to get to there. And you can look at any point. You can look at this one. It's -3, +2. And when you multiply it by 2, you get -6, +4. Either way, you should be able to tell, no matter what point you're looking at, that you're going to have a scale factor of 2, because each of those points are multiplying by 2. And then it's followed by a reflection over the y-axis. This is the y-axis. It reflects over that y-axis. The two figures are not congruent because non-rigid motions are used. Let's try to find one that is congruent. We'll submit this and see what it gives us. New problem. Okay, so these are going to be congruent. You don't have a dilation. The only thing you have here are rigid motions, and it's going to map this directly onto that. And if for some reason we did these rigid motions and you still couldn't get it on top of it, then it wouldn't be congruent. But in this case, it's going to be congruent. So first thing we have is a translation, and it's going to be down. And let's see how many units it is. We'll go from 5 down to -1, so it's going to be 6. 1, 2, 3, 4, 5, 6 if you count the boxes. So it's down 6 units, followed by, and look what's happening. It's a rotation. It's rotating, right? So rotation And these don't matter. It's 180-degree rotation, so it could be clockwise or counterclockwise. Now, in the animation, it's showing counterclockwise. That's what that is, it's counterclockwise. So you want to make sure you select whatever it's actually doing in the animation. If you went the other way, it still would give you that same exact spot, and you'd be right on top of it, but the animation is not showing that. So we want to make sure we go which way it says to. These two figures are congruent because only rigid motions are used to map I onto J. Hit submit, hit yes. Guys, that's all there is to it. This is just showing that you understand that the only way these two figures can be congruent is if one maps directly on top of the other one while not changing the size of it. Only rigid motions are used.